think
So,
it's not showing yet. Okay, yeah, it's fine now. It's fine now. Nice.
okay.
You can go on. Yeah.
Okay. So customer defection is essentially the loss of clients, and different organizations use customer defection to know the clients they should be devoting their efforts to, or concentrating their resources on, because it's less expensive uh, to retain an existing customer than acquiring a new one. So my team of machine learning engineers were presented with data from a telco company, and were to analyze data and gain insights into customer defection from it, as well as train the model to predict whether customers churn or not. So the insights from my data analysis is as follows. So first, we discovered that most of the customers use a fiber optic internet connection and a single line. And this was logical because if you do research, you find out that fiber optic connections are generally faster than DSL. Also, the customers, most of the customers do not have dependents, so it made sense that they use just a single line. Okay. Next, we found out that a larger proportion of the customers lacks additional services that would have made their user experience better. So this includes online security, backup, tech support, and device protection. As you see from this bar chart, the people with no have a higher, or occupy the higher, a larger majority of the entire of the customer base. Then found out that most of the customers that joined were on a month-to-month contract. So that's the part. This is the stack bar chart. So the blue part is the month-to-month contract. Uh, are the people represent people on the month-to-month contract, and found out that most of the people that joined were in that on that part, about 90%. Also, most of the affecting customers were new. So this is the plot of the number of churned customers against the tenures in months. That's how long they've been with the corporation. Found out that the people that churned were in that range of 1 to 3 months. So they are not spending a lot of time. They were new customers. Yeah. And this would make sense because of 1 month has the highest number of churned customers, and month to month uh, contracts also had the highest number of, or occupy the higher proportion of the churned people. So it made sense that the affected customers were new and that they were on a month-to-month basis from data. Okay, so move on to the model training and prediction. The first model we tried was the random forest classifier. So this algorithm is an ensemble algorithm. It basically combines a multitude of decision trees and outputs the class the class that occurs the most. That the mode of the class is predicted by different trees. That's why it's called the forest. So it was initialized with 300 estimators, that 300 decision trees, a maximum of 25 features, and a random set of 50. So we arrived at these figures after uh, tuning the hyperparameters to get a maximum accuracy on our test data. By the way, we split the data sets into testing and training sections. 0.2, that 20% of the data was used for testing, and we made sure that we stratified targets so that the same proportion of churned and retained customers will be in the test data and the training data. Okay, so this model gave an accuracy of 79.18 on the test data, but was seen to overfit on the training data. It had about 99.7, so it was the training data. Then we moved on to gradient boosting classifier. But gradient boosting is a sequential technique that also works on the principle of ensemble in the random forest. It combines weak learners to deliver improved accuracy. So after tuning hyperparameters, we initialize this classifier with about 85 with 85 estimators and also a random state of 15. This model gave an accuracy of 79.82% on the test data. And the final one was the CAT boost. So CAT boost is an algorithm for variable distribution trees, like the one we just considered, but it uses a symmetric tree structure, and it can also handle categorical features without needing to encode using the CAT boost classifier. We finally initialize this with a learning rate of 0.1 and 50 estimators. Its accuracy on the test data was 80.10%, which was the best of all the models considered. So after picking our best model, we decided to visualize the feature importance on the classifier. I found out that the month-to-month contracts and the tenure had the first and second highest importance, which also agrees with what we concluded from our data analysis, where month-to-month contract, where more people on a month-to-month contract churned, and the people with lower tenure also churned. So this proves that they actually have a higher influence on the prediction. So rounding up, like I just said, from the plot of the feature importance on the last slide, it's seen that the month-to-month contract and the tenure play a huge role in prediction, as was inferred from our visualizations. Also, from the modeling process, we're seeing that although the features on their own had poor correlation with the target, it was in the range of about negative 0.4 to positive 0.5. That was the range of the correlations. But with ensemble algorithms, a moderately high predictive accuracy can be achieved. Thank you.
That was a beautiful one, Forty. Very beautiful one. Thank you very much. I'm proud to ask the panelists, George, Udeme, IK, ask your questions. I'm confident.
Okay, so pretty much for me, this is very, very cool, very detailed analysis in some points, and a lot of things have been taken into consideration, which is quite interesting. But then I also thought you were going to, help us understand, or maybe I missed that point, like the data set. Was your data set balanced? If it was not balanced, how were you able to fix that? And the features, I thought I was going to see a bit of like feature correlation with each other and something like that.
So the data set was actually balanced. We just skip that from your slide. The distribution was for gender and for partners, it was roughly the same. Then when we compared the device protection and online security, the distribution was the same, which makes sense because online security and device protection, someone who protects who protects the device will most likely also have online security, so that made sense. Then mostly the data was not skewed, so it was actually a balanced data. Also, the correlation, it would have taken too much of the page. It would have been too tiny if it was to fit the page. That's why we didn't include it. But like I said, the features and the targets they didn't have very good correlation with each other. The range was from negative 0.4 to positive 0.45. So that was the range of the correlation. Sorry that we didn't put it in the slides.
Okay, any more of them?
Pretty much, I think I'm good for now.
Okay, thank you. George.
Okay. I have a question. Like, I don't really know much about churn rates, but I just have a question. So the question is, can you go back to that slide that has to do with customers with first month tenure, 30-month tenure?
This
Yeah, I think this is it. So my question is, since you have most of your customers the first month, like, right? So what does it say about older customers? Does it mean they are not really on the they're not utilizing your service? Are they leaving for other network? What does it really mean? Like that's just the question. Yeah.
okay. So first, churn rate is a negative thing. Like churning means defecting. So it means that if there are a higher number of customers that churn, yeah, at a particular, or if a specific tenure has a higher number of churn customers, it means more people that have stayed for that long left. Yeah, so this plot is telling us that more people, the majority of people that left, or rather, more people left after the first month. Yeah, and you reduce that way. So we can infer from this that long-lasting customers, say from like 15 to like 70, the height of 72. So the longer lasting customers were, I'll call them faithful, like they didn't leave. So it means it's just the people that just maybe came to test or just check out the pictures. So the people that, so a majority of people that left. But the longer lasting customers, majority of them did not go. That's why the number of churn customers in that range is low compared to that of the customers that just stayed for 10 months and below.
Okay. Then another thing I kind of noticed was that I'm more or less like I'm trying to like buttress on what the point Udeme made about. Personally, I was even expecting like you just walk us through what you did. Like I want to know the kind of challenges you had during your data pre-processing. Like want to know the missing values. But it's more or less like you are giving like an executive presentation to decision makers, which is kind of cool. But for me, I would have want to like see your pain point, like the issues you had while doing all this. And also an observation that I made was that you said something about splitting your data set into train and test. So like it's very important to also incorporate validation set. Like I'm beginning to see the need for validation set. Like it's very, very important. Sometimes people just train their stuff with train set, do the test. They'll just assume that everything will work away. But validation set is very important, especially when you want to do hyperparameter tuning. So that's just like something I've just observed. So, but personally, it's a wonderful presentation. Yeah.
Thank you, sir.
Okay.
Yeah, sorry guys, just to add to what George said, the number of churn customers on monthly basis. I'm trying to think of it from, let's drop that we are doing a project, but from the business aspects now, it's kind of very normal for somebody to just be introduced into a service and in less than a few days. I mean, how do you tell that the person has already churned when it's not even up to a month? Like from this graph, I'm seeing that, I mean, a lot of the churn guys are within 0 to 1 month, but how do you even get to know that somebody has churned when the person has not even used the service for up to a month? Or, I mean, what are your, how do I put it? What are the things you're using to really say, okay, this guy has left the service? Is it the guy hasn't used the service for like a month, or I don't really get that part.
For that question, I may not be able to give the best answer because we didn't collect data ourselves. But this plot here was collected. We had we had target data, like the whether they churned or not, and we had the tenure as a feature. So we used the group by feature and groups
Yeah.
the entire data frame into the different tenants and just make reports. But if
Yeah,
I was
unfortunately, I'm sorry. No. Don't worry. I'm sorry. I think I'm just overthinking things. Sorry that I was coming with that approach. This is like a data set you got and you had to work on. I get sorry.
It's all right. Thank you.
Okay, so good thing is that at least we all get to see experience for ourselves how data scientists think. Yeah, you have to think deep to like gain insights, just like Deme is already thinking far. Yeah, so we forgive you, Deme. Okay. Okay, Ike.
Okay. I think I'm going to talk a bit about, like George said, he would have loved to see part of your process laid out, but you chose to go for some kind of an executive where you were trying to talk to business people, not technical people. But the challenge is that though you went through that approach, I would say you were halfway, because if you were looking at it from a business point of view, you should have been able to say, okay, based on this, these are the recommendations. This is what we found out and stuff like that. Because the business is important, because at the end of the day, the essence of doing something on churn modeling is to help a business say, okay, customers that are leaving, because in marketing it is known that it is more expensive to get a new customers than it is to retain the customers. So from a business sense, you could say the 1 month-to-month customers, were they really important to the business enough? If so, my question would be, what would have happened if we removed those this large percentage of customers who really have not stayed long enough in the company to make the decision? But like, it's not your data, but like they said, this is a more technical thing, but in a business sense, that would be something you would pursue. But I think you did well. The accuracies might not be great, but maybe a little bit of more pre-processing might have helped you. Maybe you could even look at the possibility that those ones with 1 month are some kind of outliers, because they can't really help. Yes, they left. Maybe the intention was just to get 1 month and leave. So it doesn't really help you determine, because you can't really even say that they are your customers. So I would have loved to see, if you dropped them, what would have happened? Would the model have performed better or be more predictive in nature? That's something I would have loved to see. But kudos to you and your team.
Thank you. Thanks a lot.
Thank you, Keshuko. Okay, before you go, Fortune, please, can you go to the first page? Yeah, need to.
This.
No, I have bosses. So, no, not this. Okay. The first one, the very first one. Okay, just give me 1 sec. Trying to capture it. I have to make report for my bosses. No, not this. The first one, the first page.
The very first page.
Yeah. Yeah. Okay. The second one, sorry, please. Okay, so we are good. So the next group, thank you, Fortune.